we're going to talk about analyzing the EKG, the strip itself. There are actually 5 steps to the interpretation. I could add a couple more, but we're just going into basic EKG interpretation, so the others I'll wait for another day. First of all, what we want to do is be able to determine what the ventricular rate is. We want to determine the ventricular rate so that we can know what the heart function is actually doing. So let's look at that. When you determine the ventricular rate, you're going to count the number of R waves in a 6-second strip and multiply by 10. That'll give you the number of R waves, which correlate, remember, to the ventricular beat. Therefore, we should have what the heart rate would be. Now remember that this is electrical, not necessarily mechanical. Remember that the top of the paper is measured in 6-second strips. So I would go, I would double the 3 seconds. I said it was 6 seconds, it's 3 seconds. I would double that and get my 6 seconds. You with me? So let's look. From the mark at the top of the paper to the mark at the top of the paper is 3 seconds. So if I was going for 6 seconds, I would just double it. Okay? Another way is looking at it, and if you've just got a 6-second strip to analyze, you may have anomalies in the strip, and you have to determine what the underlying rhythm is and what that rate is. So you may have to just look between 2 R waves. So in order to do that and get your rate, you're going to count the large squares between 2 RR waves, which would be the RR interval, and then you have to do a calculation. Remember that there's 300 large squares in 60 seconds. So instead of memorizing and dividing into 300, if you'll just put this kind of equation to memory. 1 large square between an RR interval, the rate is 300. Okay, 1 into 300 is 300. 2 large squares in an RR interval is 150. 3 is 100, 4 is 75, 5 is 60, 6 is 50. Now notice a normal heart rate is between 60 to 100. So we write off, if you have between 3 and 5 large squares, your rate's going to be in the normal sinus rate. Okay, now look at this one. Here's an R wave, here's an R wave. The number of large squares, we've got 1, 2, 3, and then 3 little, so 3 3/5 large squares. So to get the exact, you would divide 300 by 3 3/5. However, you want an approximate because this is only an approximate, because if we're going for the actual heart rate and what the pump is doing, where do you go? You go take a pulse. So with this one, if we have between 3 and 4 large squares, we're going to be somewhere around a rate of 82-ish, somewhere in there. Okay, any questions on that? Okay. The next step is determining the ventricular rhythm. We want to know if the heart rate is in regular rhythm. Is it regular or not? Or is it irregular? Or is there irregular regularity? Or is it totally irregular? So what we want to do is see if the RR intervals are the same. Okay. Now when you're going through and identifying on your paper and answering these questions, if you just put irregular, that may not be enough information when you go back to actually say what the rhythm is. Because if it's regular and then something happens all at once and there's only one thing that caused it, you want to identify what that underlying pattern is and then what the big one is, or the anomaly is. waves. Remember, the P waves is looking at atrial depolarization. Again, we want to know what that atrial activity is. We want to look at the P waves. We want to look at their rate, their rhythm. Are they positive or are they negative? Positive being above the baseline, negative being inverted or below the baseline. And also, is there one P wave and then a QRS following each and every one of them? So let's look at some of these P waves. Here's a P followed by QRS. P, QRS, P, QRS. The P wave is positive. All the P's look alike. They're all positive. Their rhythm is pretty regular. Okay. Let's look at this next one. Here's a P, a P, a P. But it's inverted. It isn't positive. See, it dips down. We know in lead 2, if it dips down, that it cannot be from the SA node. It's being originated from the AV junction. So it is inverted, but there is a QRS following each and every one. The rate and the rhythm, or the rhythm, is regular. Let's look down here. P, QRS, T, P, QRS, T, P, QRS. What's this? Here, look here. This comes early. This beat right here comes early. What is that? So let's find all the P's. If this is a P and this is a P, let's get the rhythm going. What happened? This came early. So you have to ask yourself, is that a P wave or is it a T wave? How do you know? You have to go back to the norm. Look at the patient's normal. Look at this straight line right here. So here's the patient's normal. Okay, it's going right here. So what is this? That's a P wave. Positive P wave, but it came early. So this one right here is a PAC. Let's look at this one. Positive P, QRS, positive P, QRS. Then what happened? Why? What happened right here? The rhythm's not regular. Is this what's this? Here's the norm. What is this right here? If I went ahead and laid this right on top of this line would go straight across, and that little blip right there would be a positive P wave. But what happened? It didn't cause a QRS. This would be a non-conducted PAC. Still a PAC, but it's non-conducted. So this would be a P wave, and it would be a positive P wave. So you've got to look at your strip very, very closely. The next thing we want to do is determine the PR interval. The PR interval represents all of atrial activity, atrial depolarization, and truly all of the time that that impulse is waiting there at that AV node. It's everything above the ventricles, what time is normal for that. So when we measure it, we start at the beginning of the P wave to the beginning of the QRS. Beginning of the P to the beginning of the QRS. So this is the time for atrial depolarization and the time that that AV node holds that impulse. Okay. The normal time span is 0.12 to 0.20 seconds. That would equate 3 little squares to 5 little squares. 5 little squares is also, remember, 1 large square. Anything above the 0.20, start thinking about a heart block. Anything below 0.12, think of potentially junctional rhythm, okay? A junctional rhythm. Next, we want to look at the QRS duration. How long does it take for that impulse to travel through the ventricles to get the ventricles depolarized? And that is represented in the QRS. From the beginning of the Q to the end of the S. Beginning of the Q to the end of the S. Remember that the end of the S is back up to that baseline. Remember that QRS is pretty sharp, shall I say deflections, not going off to the side, where that J point where the QRS, the S wave ends and the ST segment begins, is right there. careful.